Hello everyone and welcome back to the channel. Today we are going to solve a fun logic design challenge. You're given two components, A and B, with the following truth table. In this table, Z means high impedance, which means we ignore it when determining logic levels. When one output is Z and the other is valid, we use the valid output. Your task, design an XOR gate using only these components. Looking at the table, we can observe the following. When the inputs are 0, 0, component A outputs 1. When the inputs are 1, 1, component B outputs 0. Let's simplify things by tying both inputs together, treating in1 and in2 as a single input. Now observe. When we input 0, both inputs become 0, 0, and component A gives us 1. When we input 1, both inputs become 1, 1, and component B gives us 0. Let's see what happens when we use them together. If we input 0, the output from component A is 1, and since component B outputs Z high impedance, the final output is 1, the exact opposite from the input. Similarly, when we input 1, the output from component B is 0, and component A is in high impedance, Z state. So the final output is 0, which is the exact opposite from the input. This behaves just like a NOT gate. Perfect, we have built a NOT gate using just components A and B. Hey, if you're finding this helpful so far, do me a quick favor. Hit that subscribe button down below. It really helps the channel. Let's look at the XOR truth table. When both inputs are the same, the output is 0. When the inputs are different, the output is 1. Now, if we look at the orange column in the truth table, we can already determine which component gives us the desired output. We know that component B gives us 0 and component A gives us 1. We will now configure each component using the NOT gate we built earlier, so each responds correctly to a specific input combination. For example, to get an output of 1 when the inputs are 0, 1, we invert input 2, sending 0, 0 to component A. We apply the same idea for the rest of the component, placing NOT gates at the inputs to produce 1, 1 or 0, 0 when needed. But wait, is there a way to make this even more efficient? Absolutely yes. Instead of placing two NOT gates at the input to component B to get 0, 0, we can just feed 0, 0 into component A and invert the output at the end. This simplifies the design and reduces component usage.